All right, last thing to learn before we take our test. It's called the factor. Well, first off, let's review. For this problem, I'm going to try to solve. Oh, everybody in the hall is really loud. It's all the band kids. That tells you I'm a little late making videos this morning. I'm worried about the band kids walking by. All right, so I'm going to do this. I'm going to divide both sides by 5. And then for some reason, I lost an x. How about we do that again? Let's divide both sides by 5. Oh my gosh. Is it going to be one of those? I should probably just stop and start over, but I'm not gonna. And I'm going to factor out my x. I'm going to recognize that this is a perfect square trinomial. It's an x minus 4 all squared because x squared is x squared, negative 4 squared, 16. Here's a negative 4x, another negative 4x. Got negative 8x. Still equals 0. So what could x be? What makes that x 0? What makes that x minus 4 0? And remember, we can say that has a multiplicity of 2. The 4 has a multiplicity of 2 because it would have shown up twice. Because I have to have 3 total answers. There's a place to get 3 answers, 3 solutions. But just to give you another term, a lot of people call these double roots. Because remember, when you're solving for x in an equation, we call the solution a root sometimes. Oops, I guess don't need plural. It's just one of them was a double root. All right, so this, I'm going to get everything on one side. Set it equals 0. I'm going to divide both sides by 2 because it's fine to divide a constant out. I'm going to factor out the x. I'm going to recognize that that's a perfect square. What makes x 0? What makes x minus 3 0? That one again would be a double root, or we could say add a let's do it the other way. 3 has a multiplicity of 2 because it shows up twice. All right, last thing to learn before the first chapter 4 test. It's called the factor theorem. First, we're just going to write down what the theorem is, and we'll show you why it works. So a polynomial has a factor of x minus k if and only if f of k is 0. All right, now let me show you an example of us just applying the theorem, and then you'll see why, hopefully see why it works. So if we're trying to decide if x minus 2 is a factor of this, okay, well, this is kind of a little bit silly because we could just see if it factors. But if you want to know if x minus 2 divides into this evenly, that's the question. Then let's do synthetic division because we're just dividing by x minus 2. Put the 2 in the box. 1, 2, negative 4. Was the remainder 0? No. Okay, that means that, like we already know what the answer would be. It would be an x plus 4 out of x minus 2. So that means x minus 2 is not a factor because the remainder wasn't 0. It did not divide evenly. So no. It is, I guess we should write out since it's x minus 2 is not a factor of x squared plus 2x minus 4. But here's the thing. You'd had to have an x. You'd had to have a positive 2. That doesn't give you, like we could have known that other ways. But sometimes it's hard to know it other ways, and this is a good thing to do. Okay? The next one, is x plus 4 a factor of this? Well, let's see. Let's put a negative 4 in and do our synthetic division. X cubes, x squareds, x is constant. Is the remainder 0? Why, yes. Yes, it is. So is it a factor? Yep. Now think about how we can use this. Besides the fact that I could have just factored that to begin with. Now I know x plus 4 is a factor. And here's what's left over. Remember, drops of power. If we start out x cubed, there's 1x squared minus 5x. And then out of here, they have a greatest common factor. I could take the x out. And it just looks weird not to put it in the front. And then we had the x plus 4 already. When I took the x out of here, it left me x minus 5. So x is either 0, -4, or positive 5. Now, did I need to know all that? Absolutely not. I could have factored the x out. It's a trinomial. What multiplies to be -20 adds up to be -1. That's a -5 and a positive 4. Like, I could have done it that way and been just fine. But again, sometimes you can't, so we're practicing a new skill. So this one, show that x minus 2 is a factor, which means show that when you divide x minus 2 into x to the 4th minus 2x cubed plus x minus 2, you get a remainder of 0. So x to the 4th, x cubed. There is no x squared. X constant. Yep, it's a factor. And it says now factor this function completely. So if we know that x minus 2 is a factor, we know that here's what's left. When we start out x to the 4th, depressed polynomial, you drop a power. No x squareds, no x's, there's a constant. But x cubed plus 1 is a sum of 2 cubes. Would you cube to get x plus would you cube to get 1? Square, change the sign, times them, add in the square. So there's the complete factorization of this. Again, could we have done this other ways? Of course. Well, I say of course like that's always going to happen. On this one it would have. Like I could have factored by grouping and said let's take an x cubed. And then let's take a 1. And then there's an x minus 2. Here's an x cubed plus 1, and then that's go from there. Okay? Given that this is a factor, okay, so they're telling you x minus 6 is a factor. We're going to factor this function. So 1, -6, no x squareds, -8, 48. 0, 0, 0, 0, -8, -48. There's my remainder being 0, which holds up that fact. Yep, it's a factor. So g of x is this, which if 6 divides, do the synthetic division with 6 comes up remainder 0, that means x minus 6 is a factor. Depressed polynomial, x cubed minus 8. Difference of 2 cubes, x minus 2, x squared plus 2x plus 4. Again, could you factor by grouping? Heck yeah. This one, we know that x plus 7 is a factor. So if I do synthetic division, x cubed, no x squareds, x is constant. Yep, that confirms x plus 7 is a factor. So this time around, though, they want you to solve this function being set equal to 0. Okay, so I know that x plus 7 is a factor. Here's what's left. X squared minus 7x plus 12. And then this factors again. So x is either -7, +3, or +4. And again, I know I'm going through this quickly, but there's only a couple people at home. So I'm really kind of just talking to you, and you have a pause button and a rewind. So that's why I'm just trying to knock this out as quick as I can this morning. Oh, that was the last one.